Hello class, in today's lesson we're going to be looking at sketching parabolas using transformations. The first thing we're going to be doing is we're going to review the different types of transformation. So this includes dilation, reflection, and translation. We're going to understand how these transformations actually affect the graph y is equal to x squared, which is also referred to as the parent function. To know how to determine the turning point of a quadratic rule from the turning point form, to be able to sketch a quadratic from the turning point form, and lastly we're going to be able to find the rule of a quadratic given the turning point as well as another coordinate. Now if you guys recall, I showed you different ways that you could actually represent a quadratic equation. Okay, so this could be represented either in the standard form, in the turning point form, or in the factorized form. Now, something that I probably might not have made explicit is that in all of these three forms of here, you could actually convert from one form to another form. But notice that I've actually deliberately color-coded A for each of these forms in red, because what I'm trying to show you is that when you do convert from one form to another form, the value of A will remain the same for each of them. But you'll notice that the other letters like B, C, H, K, these will actually differ amongst these forms here as you convert from one form to the other form. What I'm going to show you right now is I'm going to show you the respective strengths for each of these different forms over here. So in this case over here, I'll firstly go through the strength or the advantages of representing quadratics in the standard form. And that's that it readily tells you what is your y-intercept. Now notice over here, I've actually showed you how do you actually write down the y-intercept as a pair of coordinates, and that's the way that you should be doing things. So 0, c, 0 because the y-intercept is always at 0 where x is at going to be. So in this example over here, your y-intercept is going to equal to +1, and I represent that by this particular coordinate over here. Another thing that you could also find quite readily as well is the turning point, but I want to show you how to do that in future lessons. So don't worry about this particular point, which is the reason why I've included it as asterisk. Just know for now that you can readily tell what is going to be your y-intercept. Now for this question over here, I want you to now state what are the y-intercepts for the following questions in coordinate form. So give yourself a minute and then compare answers. If you guys have done this successfully, the first one is going to be -8, so 0, -8. And the next one over here is going to be 0, 16, okay? It doesn't really matter what these values are going to be. It doesn't affect your y-intercept value at all. Now, I'm going to go through the advantages of the turning point, and as the name implies, the turning point form readily tells you what is your turning point going to be. Now, in the last lesson, I told you guys that if you want to find out your turning point, it's always going to be the opposite value of whatever is inside the actual bracket, and this value here stays the same. So whatever that value is positive, then you read it as it is, okay? So in this example over here, notice that you've got a -1 and a 2, so therefore your TP is going to be the reverse of that. So that's going to be a +1 and a -2. So that's going to be a turning point, and that's shown, illustrated clearly in this particular diagram over here, okay? So what I'm trying to show you is that your Ka value remains the same, but the H value, just make sure that you remember to flip it. Another strength of this is that in the turning point form, that's the only form that will show you all transformations. The other forms can't show you horizontal translations. This particular form over here can clearly show you what is your horizontal as well as your vertical transformation translations. That should be translations over here. So for these questions right now, I want you guys to quickly identify what is the turning point for each of these following graphs. This should take you about a minute. So if you guys have done this correctly for the very first one, notice that this one over here, there's no translations whatsoever. So therefore this is going to be 0, 0. In this case over here, I can rewrite this in the turning point form. So that's going to be something like this: x plus 0 whole squared plus 3. Notice that the equation is still exactly the same, but now that I've written it in the turning point form, I can see that it didn't move at all horizontally, but it did move vertically. So therefore the turning point is going to be 0, 3. Because it didn't move along the x-axis at all. That's why it's 0. For this one over here, to help me understand it, again, I'll do the exact same thing where I'll rewrite it in the turning point form. So it'll be x plus 0, okay? And I'll put a negative sign over here, whole squared, take away 4. In this case over here, again, no, you're not moving horizontally, but you did go down, okay? So therefore, your turning point is going to be -4. For this question over here, I can rewrite this as +0. So therefore, it didn't move up or down. It did move to the right, however. So therefore, this is going to be 2, 0. The next one is going to be -5, 0. And the next one is going to be 0, 0. Okay. All right, and lastly, looking at the advantages of the factorized form, we said that in the factorized form, this will actually tell you what your x-intercepts are quite readily. And I did mention to you guys in the previous lesson, similarly like how you were trying to identify the turning point, you're always flipping the values when it's inside the actual bracket, okay? So in this case over here, I've got my equation x plus 3, x minus 2 shown down here. So therefore, your x-intercept is going to be -3, and that's clearly shown right here, and +2, which is shown right over here. Okay, so that's pretty much how you can find x-intercepts when it's in the factorized form. So have a go identifying what are the x-intercepts for the following 3 questions. If you guys have done this successfully, then you will have said that for the first one's going to be +2, 0 and 6, 0. The next one's going to be 5, 0, -4, 0, and the last one's going to be -1, okay? So there's only one x-intercept for this particular graph over here. It will look something similar to this, so notice it just only touches the graph once. Now, I've just shown you all these different forms, and I'm trying to show you that because there are certain advantages for each of these particular forms, it is useful for us to learn how to convert between these different forms. So what I'm trying to show you is, before, again, I said that the factorized form allows us to determine what x-intercepts are. Your standard form rarely tells you what your y-intercept, your turning point form tells us the turning point. So therefore, by learning how to convert between each of these forms, we can therefore have a different piece of a puzzle, and therefore we could actually graph the complete parabola. That's what I'm trying to show you right over here. So what do I mean by this? Well, as you can see in my example over here, I've got the equation in the standard form. And as I said, in the standard form, this is only useful for telling me what your y-intercept is going to be. And I can see that my y-intercept is going to be -3, so 0, -3. Now, in order to paint the full picture, I need to find out what my x-intercepts are going to be, as well as my turning point. From our previous lessons together, you should be able to factorize this particular quadratic equation in order for us to find your x-intercepts, okay? So if I was to factorize it using the product sum method, this is going to be my answer over here. And now that it's in the factorized form, I can therefore readily tell what is my x-intercepts going to be. It's going to be +3 and -1. So I'm going to rewrite that in as a pair of coordinates. And if I wanted to find out what my turning point is, I need to therefore convert it into the turning point form, okay? And if I've done that, then this is what it will look like. We haven't explored how to do this yet, so you don't need to actually worry about that. But now that's in the turning point form, this is going to be my turning point over here. It's going to be the opposite of this, so that's going to be a +1 and a -4, okay? And once I've got all of the main features, I can therefore actually plot and draw my actual parabola, okay? So therefore, if I plot it, this is what my actual graph would look like. What I'm trying to reinforce again is that despite having different equations, okay, each of these equations can be converted from one another, and they can still produce the exact same parabola despite looking a bit different. What I'm going to do right now is I'm going to quickly review over different types of quadratic transformations that we've explored in our previous lesson. Remember, we said that a transformation was just changing the position, the size, or the shape of a parabola. Now, in this particular animation down over here, I'm trying to show you how this is applied in the turning point form. So notice I'm just changing the value within the bracket. So I'm changing the value of h. And notice that when I'm moving to the left, it's a plus sign. But when I'm moving to the right, it's going to have a takeaway sign. Okay, that's why I said it's going to be the reverse in this case. So this is a horizontal translation when you're moving. In this example over here, this is an example of a vertical translation. So you're moving up and down the vertical y-axis, okay? So when this is a negative number, it goes down. When it's a positive number, it goes up. The next type of transformation we're looking at is a dilation. And dilation just means changing the size of it. So based on, is it getting thicker or thinner? You'd notice that when it's a smaller number, so when it's a fraction, okay, you'd notice that it's going to be a lot more wider. But as this number increases, when the value of a increases, you're going to get a very thin graph, okay? And lastly, reflection just means flipping the actual parabola. So from a happy face to a sad face parabola. So that's all there is to it. I showed you this particular slide over here. So again, I'm showing you that in this case over here, A represents the dilation as well as reflection. You don't need to worry about B at all, as I said. C over here for the standard form represents your vertical translation. But what I really want you to memorize is mainly this part over here, because when it's in the turning point form, as I said, you could find out all the different types of transformations applied. This particular form over here doesn't show you the horizontal translations at all. And I got you guys to copy this particular notes down in your exercise book. So if you haven't done so already, make sure you include this. Now, if you're still struggling to identify what transformations have been applied, my suggestion to you guys is that I recommend that when you do get an equation, I want you to try to convert it or express that particular equation in a similar format in the turning point form, okay? So if it doesn't look like it's in the turning point form, try to make it look like it's in the turning point form without actually changing the actual question or the equation itself. So I'm going to show you a couple of examples to show you what I mean by this. So in this case over here, I've got a quadratic equation, okay? So I've got a binomial quadratic, 2x squared plus 4. And in order for me to identify what transformations is present, I'm going to make it look something similar to this over here, okay? Now, a in this case is always going to be the coefficient in front of x. So therefore, you can see already that a is equal to 2. So therefore, I know this is what my equation would now look like. So it will be y is equal to 2 bracket x minus h whole squared plus k. I need to find out the values of h and k as well. Now, in this case over here, k is pretty much the constant, the number that's by itself. So therefore, k is equal to 4. So therefore, this is now what my equation would look like. So what's the value of h? Well, in this case over here, you can agree with me, or you should be able to say that h in this case over here is equal to 0. I can rewrite this equation like this over here, and you know that anything with a 0, we don't really include it at all. But if I was to write it like that, then this is how I would write this in the turning point form. So that's what I'm trying to say, that these two over here are identical. It's just that you don't really include zeros most of the time because it doesn't affect the actual equation at all. So now that it's in the actual turning point form, so this one over here that I've actually rectangled, you can see that your turning point is going to be 0. So there's going to be no horizontal translation, but it did go up 4 units though. So we know that there is a dilation of 2, which means that it's going to make it thin, and there's going to be a vertical translation as well, moving up 4 units. In my second example over here, I'm trying to rearrange this or express this in a similar format like the turning point form. In this case over here, your value of a, which is the coefficient, is going to equal to -1. Your value of h is already given. That's going to be equal to, in this case, -1. Remember, it's always going to be the opposite when it's inside the bracket. And now in this case over here, to find out your value of k, in this case, because there's no numbers over here, k is just essentially equal to 0. So therefore, when it's now written in this particular format, I can clearly see that it's moved 1 unit to the left, and it hasn't moved at all vertically. So therefore, there's going to be a reflection, because a negative indicates you're going from a happy face to a sad face. And there's going to be a translation 1 unit to the left. What I want you to do right now is I want you guys to have a go answering these 3 questions. So give yourself 2 minutes and then we'll compare our answers. If you guys have done this successfully, for the very first one, you should have recognized that this is going to be dilation. So it's going wider because this is a fraction. It's a smaller number than 1. And this -6 over here indicates you're going 6 units down. For question 2 over here, what transformation is present? This is going to be a reflection, but also a horizontal translation moving towards the right because it's the opposite of this. And for the very last one, it's going to be a horizontal translation to the left of 1 unit and going down 1 unit as well. Now, just to get a bit more practice, guys, I highly recommend that you please answer these questions over here. So for question 3, I don't think I asked you to do all these questions. Actually, I just want you to do just maybe the first column for question 3, first column of question 8, as well as question 9. So please do this. This should take you about 10 minutes, so not too long at all, and then continue the rest of the video. What we're going to be looking at now is we're going to be looking at sketching parabolas. So that's the main focus, well, one of the main focuses of this video. So again, in order for you to accurately draw a quadratic, you need to know these particular 3 features. You need to know the x-intercepts, the y-intercepts, as well as the turning point. However, because this is more of an introductory lesson in terms of sketching, we're going to be learning how to draw a very crap parabola, because we're only going to be drawing or plotting 2 useful features out of the 3. We're only going to be including the turning point as well as the y-intercept. And in the future lessons, I'll show you how to actually solve to find the x-intercepts. So for now, all of your parabolas is probably going to be inaccurate, but it's going to be fine for our current level of understanding. So I'm going to show you a couple of examples. In this example over here, you're trying to sketch the graph of y is equal to x minus 3 whole squared minus 1, labeling the turning point as well as the y-intercept. So in this case over here, because it's already expressed in the turning point form, you'd agree that your turning point is going to be positive 3 and negative 1. And once we've got that over there, that's going to be quite easy. Now let's find out what is your y-intercept. So to find out the y-intercept, that's where it crosses the y-axis, and that's the x value of that point is going to always equal to 0. So let's sub x equals to 0. Once we've done that, then this is what your equation will look like. So what is 0 take away 3? Well, that's going to be negative 3. Negative 3 whole squared, that's going to give you a positive 9, okay? So y is therefore equal to 9 minus 1. Simplify that, y is therefore equal to 8. So therefore, that's going to be your y-intercepts. So now let's plot those 2 coordinates together. So therefore, these are the coordinates over here. That's your y-intercept. That's going to be a turning point. So the turning point, remember, that's where it dips, okay? Or does the little U-turn. And in this case of here, because a is equal to 1, that indicates that you're going to have a happy face parabola. So let's connect the dots together. So therefore, this is what my parabola would look like. Now, in this example over here, I want to emphasize that it's going to be a crap parabola because you don't know exactly what your x-intercepts are, and that's okay for now, okay? So don't stress at all if you don't know how to find the x-intercepts. In my second example, I've got the equation y is equal to negative x plus 1 whole squared plus 4. So again, in this case over here, the turning point for this question is going to be negative 1, positive 4. In this case, I also know that this is going to be a maximum, so I'm going to have a sad face parabola. Let's find out the y-intercept by subbing in x is equal to 0. So therefore, this is what it looked like. Well, we know that 0 plus 1 is 1. 1 squared is equal to 1. But because there's a negative sign here, therefore, that's going to make it a negative 1. So therefore, negative 1 plus 4 is equal to positive 3. So y-intercept is equal to 0, 3. We'll plot both of these 2 coordinates together. We said that this over here was your turning point, so that's where it's going to start dipping. Therefore, just draw a curve that connects these 2 dots. This is what you should get. And as I said before, don't worry about where the position of your x-intercepts are going to be. All right, guys, what I want you to do now is I want you guys to answer this question. So identify which parabola corresponds to the quadratic equation shown below. Now, if you guys have done this successfully, what you should have done automatically is that you should have crossed out these 2 graphs over here because these ones are happy face parabolas. You've got a sad face parabola, okay? And in this case, your turning point is going to equal to positive 2, negative 4. And the only one that has a turning point with positive 2 and negative 4 is going to be option B. So B is going to be the correct answer. What I want you to do right now is I want you to have a practice sketching these graphs over here. So give yourself 20 minutes or so, and I highly recommend that you do all of these questions as I've shown. I've actually reduced the number of questions you've done. There's supposed to be like 3 columns here, another column here, another column here. So have a go. That's about like 10, 15 questions, and this should get you enough practice of sketching. We're going to move into the last part of today's lesson, which is how do you actually find the equation or the rule for a particular parabola using the turning point formula. Now, when the turning point as well as one additional coordinate other than the turning point is actually given, we're going to be using the turning point formula to determine the equation for that particular parabola, okay? As I've shown you beforehand, there are many ways you can represent a quadratic equation. You can do it in standard form, turning point form, or the factorized form. But it makes sense that when you know what your turning point is, you're going to be using this particular equation over here to actually find the rule. You're not going to be using this one because this one only tells you what your y-intercept value is, and this one tells you what your x-intercept values is. For this particular example over here, if I was to try to find what the actual equation is going to be, I could again use the turning point form because I know what the turning point is, but I could also use the factorized form, and I won't be going through that particular example, but we can use this form over here because I know both of the x-intercepts. Again, I can't use this form over here. So to find the equation of a parabola, I've actually broken this down to two main steps. What you need to do first is substitute the turning point into the turning point formula, followed by substituting the other coordinate and then solving for A. So let's use this parabola shown on the right hand side as an example. So your turning point, as you can see, is going to be 0, 1. Okay, so therefore let's sub that into the turning point formula. Therefore, this is what it's going to look like, right? So therefore, if I simplify this, because that's a 0 there, I can pretty much neglect it. So therefore, this is going to be my equation temporarily. I now need to find out what my value of A is going to be. And the way that I do that is by substituting another coordinate. I don't substitute this coordinate. I have to substitute the other coordinate, okay? So therefore, it's going to be 1, 2. So therefore, substitute it in. 1 squared is equal to 1. And now I'm going to rearrange to solve for A. So subtract 1 from both sides of the equation. Therefore, A is going to equal to positive 1. Therefore, substitute your value of A back to the equation. Therefore, this is going to be your answer over here. Okay, so pretty straightforward. I want to show you a more complex example because that's the kinds of examples that you're going to be dealing with mainly on your topic test. So in this case over here, find the equation for the parabola below. Again, I'm going to identify what's my turning point. My turning point is going to be positive 1 and negative 4. Sub that into the general equation of the turning point form. And in this case over here, once I've done that, then I'm going to substitute this one of the x intercepts. In this case, I've decided to use this one over here. So I'm going to substitute 5, 0, and therefore this is what your equation would look like. 5 minus 1 is equal to 4. 4 squared is equal to 16. So it's going to be 0 is equal to 16a minus 4. What I'm going to be doing is I'm going to move 4 to the other side. So I'm going to plus 4 to both sides of the equation. That gets rid of this. Therefore, you're going to get with 16a is equal to positive 4. I've just flipped it around. And therefore, divide both sides by 16 to get rid of the coefficient. A is therefore equal to 1 over 4 once you've simplified it, okay? Therefore, substitute it back into the general equation. So therefore, your answer is going to be y is equal to quarter x minus 1 whole squared minus 4. So this is a more complex example over here that I've gone through. What I want you to do now is I want you to have a go answering this question. Give yourself 3 minutes, refer to my example, and then we'll compare our answers together. If you guys have done this successfully, again, find out where your turning point is, sub it in, and then afterwards substitute the other coordinates and therefore solve for A. A is therefore equal to positive 2, sub it back in. This is going to be your equation over here. So what I want you to do right now in terms of answering the textbook questions for questions similar to this, I want you to answer questions 5 as well as question 6. This is a really good one here. This is compulsory. Don't try to skip this question. This over here is going to unlock and increase the number of brain cells you have. And this question over here is going to be a worded problem, but I don't think this is a bit too hard. It's more interpretation wise though. This is going to be the end of today's lesson. Thank you guys for watching. Hopefully you guys are able to meet the success criteria. I'll see you guys again in the next video. Laters.